Hello. Today, we're going to learn about alcohols, carboxylic acids, and esters. Here's the lesson outline. Alcohols. Here are the success criteria. Do make sure you are able to achieve all these at the end of the section. Alcohols are organic compounds with the hydroxyl functional group. The hydroxyl group is connected to the terminal carbon. The terminal carbon is the carbon at the end of the carbon chain. The diagram shows how propanol, an example of alcohol, looks like. Here are more examples. You will need to know how to name, draw the structural formulae, and figure out the molecular formulae of alcohols containing 1 carbon to 4 carbons. We can form isomers of alcohols by shifting the hydroxyl group or the alkyl group. Below are examples of isomers of butanol, an alcohol containing 4 carbons. Can you identify how the hydroxyl group or alkyl group is shifted? Did you manage to identify them? Next, let's take a look at the physical properties of alcohols. Shorter chain alcohols are volatile liquids at room temperature and pressure. The alcohols have higher melting and boiling points compared to hydrocarbons with the same number of carbons as shown in the table. There is a gradual trend in the solubility, melting, and boiling points of alcohols down the group as shown in the table. Next, let's learn about the chemical properties of alcohols. You will need to be familiar with the various chemical reactions that alcohols undergo. Firstly, combustion. Alcohols undergo complete combustion to form carbon dioxide and water. This is shown in the equation below. Next, most alcohols undergo oxidation when heated with acidified potassium manganate. Alcohols with the hydroxyl group bonded to the terminal carbon are oxidized to form carboxylic acids. All these are shown in the equations listed below. Lastly, alcohols react with carboxylic acids to form esters. This is known as esterification, which you will learn in the later chapter. After learning about the reactions of alcohols, now let's learn about the formation of alcohols, particularly the formation of ethanol. You will be learning 2 methods to form ethanol. Firstly, we can form ethanol by the catalytic addition of steam to ethene. In this reaction, ethene reacts with steam to form ethanol at 300 degrees Celsius, 60 atm, and phosphoric acid as catalyst. This method is not a sustainable method as ethene is obtained from crude oil, which is a finite resource. The second method is the fermentation of glucose. This reaction is more sustainable as the starting materials are obtained from plants. However, this method is slower compared to the catalytic addition of steam to ethene. And that is all you need to learn about alcohols. Let's learn about carboxylic acid. Here are the success criteria. Do make sure you are able to achieve all these by the end of the section. Carboxylic acids are organic compounds with the COOH functional group. Carboxylic acids have the general formulae as shown. You will need to learn how to name, how to draw the strictures and the molecular formulae of carboxylic acids containing 1 to 4 carbons. Carboxylic acids have higher melting and boiling points compared to alcohols and hydrocarbons containing the same number of carbons. Carboxylic acids are generally soluble in water. They also show a gradual trend in their boiling points. Their boiling points increase as the molecular size increases. Carboxylic acids are weak acids. They partially ionize in water to form a carboxylate ion and a hydrogen ion. Like other acids, carboxylic acids also react with reactive metals, carbonates, and base. In these reactions, the carboxylic acids exhibited the characteristic chemical properties of acids. Lastly, carboxylic acids react with alcohols to form esters as mentioned previously. Next, let's look at the formation of carboxylic acids, in particular the formation of ethanoic acid. There are 2 methods that you need to learn. Firstly is the oxidation of ethanol by atmospheric oxygen. In this reaction, ethanol is oxidized by atmospheric oxygen in the presence of bacteria to form ethanoic acid and water. The second method is what we used in the laboratory. Ethanol is heated with acidified potassium manganate to form ethanoic acid and water. In this reaction, potassium manganate acts as the oxidizing agent while ethanol acts as the reducing agent. And that's all you need to learn about carboxylic acids. Lastly, we come to the last section on esters. Here are the success criteria. Do make sure that you are able to achieve all these at the end of the section. Esters are organic compounds formed by the reaction of alcohols with carboxylic acids. Esters contain carbon, hydrogen, and oxygen. The diagram shows the full structural formula, functional group, and the model of ethyl ethanoate, a type of ester. The general formula of an ester with one ester linkage is as shown. It consists of one part from the alcohol and the other part from the carboxylic acid. The reaction between an alcohol and a carboxylic acid is as shown. The diagram shows what happens when an alcohol reacts with a carboxylic acid. Spend some time to figure out how the water molecule is removed. In summary, in the formation of an ester, the OH group is removed from the carboxylic acid, and the H is removed from the alcohol. Esterification is also known as a condensation reaction because two molecules react to form a single molecule with the loss of a small molecule. Water, the small molecule, is lost in this case. Do note that this is not an acid-base reaction, as alcohol is not a base. Alcohols do not dissociate to form OH negative ions in water. Lastly, we come to the naming of esters. The name of an ester consists of two parts, one part from the alcohol and the other from the carboxylic acid. In the example shown, the ester is made by reacting methanol with ethanoic acid, hence the name methyl ethanoate. We need to identify the respective alcohol and carboxylic acid that made up the esters in order to name the esters. Here are some more examples for practice. Do take some time to figure out the naming process. Seek consolations with your teachers if you need to. Here are the steps in naming the esters. Step 1. We identify the functional group. This is shown by the blue circle. Step 2. We identify the part that comes from the alcohol. This is shown by the red square. Remember, the H atom is removed from the alcohol during the formation of the esters. Hence, we look out for the O bonded to the carbon when identifying the part that comes from the alcohol. Step 3. We identify the part that comes from the carboxylic acid. This is shown by the orange square. Remember, the OH group is removed from the carboxylic acid during the formation of the esters. Hence, we look out for the O double bonded to the carbon when identifying the part that comes from the carboxylic acid. That's the end of this chapter. Do seek your teacher's help if you need clarifications regarding this